Yeah.
Whether it was
That's okay. My son speaks Japanese.
Roman and South.
Oh gosh.
That'd be a hard one to learn.
Yeah.
For Americans, I think.
Yeah.
He speaks fluent. French, he speaks it really bigly.
Oh really?
I don't go to Italian on air. So he decided he would take Chinese.
Yeah.
Now he's fluent in Chinese. Wow.
Huh.
There we go. Now we've got them over here.
Can he write it? Yeah, oh yeah.
Collapse them.
Yeah,
Takes some talent.
my son speaks Japanese fluently, but I mean that's a tough language. But Chinese is far worse.
Well, all those Asian languages,
Characters.
they're hard to learn. They're hard to speak. The characters are quite similar.
Okay.
They appear.
Yeah, but they
You guys ready?
they have a
All right.
larger
Roger, you ready?
vocabulary. Sure, go ahead. Go for it.
Okay.
We're all waiting in
Let's get
bated
going.
breath.
We are fortunate today to have Dan Brett with us. Dan is manager of, you've been throwing the title, I'm not sure what it is. Manager of IGU, formerly of FNG, and we're glad to have you here today, Dan. Thanks for coming.
Yeah, thanks. Appreciate the opportunity to give everybody an update. So what I thought I'd do this morning is I'll give you an update on the storage project that we're working on South Fairbanks at the end of Pega Road. Some of you have seen a few of these slides before, but we're making great progress on the project, so I'll give you an update. And given all the activity that's happened in the last number of weeks, and with the close of the sale between IGU and Ada, now IGU owns all of the assets related to providing natural gas service to the community. I thought I'd open it up for questions and just a discussion if we want to have that, and just answer questions. I'm sure there's probably some interest in the activities that have been going on related to the Siemens proposal and the other work that we're doing. We're actively working on North Pole storage facilities right now too. So we've got a lot going on. I know it's a lot to keep track of for everybody that's not involved in it on a day-to-day basis, but we'll do our best to keep everybody informed. So first, I'll give the large LNG storage tank construction update. If you people will recall that have heard me present before, we signed a contract on December 26th and began the work on December 28th of 2017. We completed the tank excavation in February, flat loop evaporators in March. What those are is keeping the ground frozen during the construction activities. And so we're keeping the ground at 25 degrees underneath the tank so that the ground stays frozen. We poured the tank slab in April 12th. It was about 1,800 yard pour done in a single day. And the first panel of the outer tank was poured in Anchorage on March 30th. And we set the last panel in place on June 21st. The cover plate welding was completed by July 10th, and the wire winding, shotcrete, and dome roof fabrication is ongoing right now, with the dome roof substantially completed with a expected lift date September 9th, or plus or minus thereabouts. We've also started the what I'll call balance of plant work, which includes a multi-purpose building, our truck unloading facilities, our pipe trenchways. That contract is being completed by JGC Inc., a local contractor with subcontractors of Great Northwest, Rady Concrete, Fulford Electric. So again, a lot of the, although the main tank contract is with a company out of Quincy, Massachusetts, a substantial amount of their work is being completed by local Alaskan contractors. All of the civil works have been done by Great Northwest as far as the ground preparation, all the concrete work, as far as the slab was done by Rady. Fulford's done all of their electrical. Local crane companies have been completing all the crane work, and a substantial amount of, and the tank panels were done in Anchorage by Alaska companies. So a lot of the work is still being done by Alaska contractors. feel free if anybody has a question as I'm moving forward to interrupt me and what can answer it at any time. This is really kind of how the site started out early in January. In January, this is the flat loop evaporator system that was being installed. You can see the substantial part of the excavation work has been completed, but it was still ongoing at this time. This is after that work was done. The concrete slab was poured, and the tank panels were being erected. They were erecting 5 panels a day, so it was a very smooth process. That once it started, it just each day they were putting in 5 panels at least. So a truck would show up with a panel on it. The cranes would lift it. The truck would leave, and another one would stage, and then the trucks would start coming back in the next evening. This is the substantially completed with all the outer panels up. So once the outer panels are up, you can see the gap between the panels. There's a cover plate that goes on there. That cover plate is welded both outside and inside and has studs on it. So when they shotcrete the inside, it's to retain the concrete. This is the shotcreting of the inside of the tank. So you can see that gap between the 2 tanks where the cover plate was installed. They come in and shotcrete that after all the panels were up. This is how it looks after the shotcreting is completed. It's kind of a neat picture with the way the sun or the shadows were falling that day. But you can see it's one continuous flat concrete inner tank. This is the dome roof. They're building the dome roof just to the side of the tank construction. That dome roof will be lifted and placed as a single unit. The dome roof getting substantially completed. What's the construction material on the? It's carbon steel on the dome roof.
Way back when before the Trans-Alaska Pipeline was at Rice University, and he reported that time that somebody had done ballistic tests on how you could penetrate the pipe with a rifle. Have you done ballistic tests with?
We've had discussions.
A lot of people with guns out there, you know.
We've had discussions. The concrete tank before the wire winding and shotcrete is 10 inches thick. After the wire winding and shotcrete, there's another 3 or 4 inches added. The wire winding is 0.19 inch, and it's tension to 0.166 inch, and that creates about a 40,000 pound tensioning on the wire winding, and it's shotcreted in. They've installed 320 miles of 483 miles of wire winding that's around that entire tank. So when we talk to the engineers about it, they've done some work on some of the larger FERC tanks that are onshore for like plane collisions with the tanks, etc. And we expect that this tank would withstand definitely a rifle shot. There's also a 3 foot of insulation between the outer tank and the inner. So anything that was able to penetrate the outer tank, its velocity would be dissipated in that 3 feet of insulation space before it ever reached the inner tank.
What is the insulation?
It's perlite. Yeah, so we expect that it would actually take a direct impact from a small plane.
The right answer.
Yeah. So this is the tank as it looked when they're just starting the wire winding process. You can see at the bottom, and some may recall, we didn't have a picture of it here, but the bottom has been shotcreted where the plastic is overwrapped. That's where the seismic restraint cables came out of the foundation. They came out of the foundation and were all around the tank bottom. Those have been shotcreted in, and then as they wire wind, then they get compressed, and so that's what holds the tank from any seismic issues related to earthquakes. So the wire winding, this machine that they have, proprietary equipment to this tank manufacturer, up on top of the tank is a rail that winds around the tank with that caddy that you see, and it goes around the tank. And David, how quickly did it go around the?
About 45 seconds.
45 seconds they would go around the tank. So it's moving. Yeah. Here's a kind of, you can get a better feel for how much cable is going on this for in the wire winding process. Shotcreting of the outer tank, once they wire wind, you can see them shotcreting up to the left there.
How thick is the wire winding?
The wires are 0.20 inch, and they, how many layers are they winding?
17.
So,
Over 3 inches.
It's several inches thick once they're completed and done the shotcreting. You can see the plywood there in the picture that has the windings over it, and around it you can see, I don't know if you can tell, but there's fasteners on the edge, those white looking units. That's the temporary construction opening that they closed for the wire winding and shotcrete process. Those fasteners then, that's where they clamp the cables and keeps the cables under tension. So they'll cut that out again once the first phase of the wire winding and shotcreting is completed. When the inner tank is complete, and they will reclose this and then rewind that bottom of that tank over that construction opening again. So that's where they'll access the inner tank, or access the tank and be able to begin constructing.
Will they take the wire off of there and put on new, or just right over the top of that?
Right over the top. So that's why those fasteners are there, so that all the wire that's around the full circumference of the tank now, including the temporary construction opening, they'll clamp that wire so it stays under tension, and then they'll cut it in the temporary construction opening. And then that way the tank stays under tension during the construction of the inner tank and through the final testing. And then they'll then the temporary construction opening is closed for permanently, and then they wind again on the bottom. Just another view of them doing the winding and various stages of the shotcreting. This is just a general site layout. You can see the tank up to the north, the multi-purpose building, and then our truck unloading facilities. So the multi-purpose building is where our control center will be, in addition to our heat source for the vaporizers. We will have initially 4 6 million BTU boilers installed. So we'll have redundancy in our heat source. Ultimately, it's sized to have 7 boilers in that facility. Those supply heat to, I don't know if everybody can see the LNG vaporizers that are just to the south and west of the pipe run that's coming down from the tank.
Dan, can you point at those with the mouse?
LNG vaporizers here.
Thanks.
So what we're installing is 3 50% or units, so 24 million cubic feet a day of capacity in each one of those vaporizers, ultimately for 48 million cubic feet a day of capacity we can send out into the system. To put that into perspective for you, our current peak is about 6 million. So a substantial amount of expansion capability. Right here is the spill impoundment. In the event we were to have any spills at the tank or in the pipe run here, the spill would run here and be contained in this impoundment. These are all underground concrete trench boxes. So all of our piping will be in a concrete trench box. If there's ever a leak, it's retained in that trench box and into the spill impoundment. That also keeps the above ground area free from pipes. So it keeps the site clean. We will have heat in those trench boxes in the bottom, so any snow or rain will be dissipated to keep them free and clear. And we'll also have cooling actually under the spill impoundment area, given its proximity to the tank, so that the ground stays frozen. Right, this outer ring here right now is depicting thermosiphons, vertical thermosiphons. We're in a process right now of called value engineering. This section we may end up putting in a flat loop system instead of these vertical thermosiphons, so we don't have to have vertical thermosiphons up above the ground, which will make access for us much better in the future. But we haven't come to a final conclusion on that yet. We're still working on the details. Boil-off gas compressors here. So the tank is designed for 2.5 pounds of maximum operating pressure. We'll operate the tank at about 1.5 psi. The boil-off compressors, what they do is they take any boil-off gas that naturally, as the LNG sits in the tank, it warms, it boils off. Any of that boil-off gas gets compressed and sent out into the distribution system. So we don't have any venting or any of gas leaving the tank. It's all contained. I have our meter and odorization system. So this is where we'll measure the gas leaving our site and we'll inject the odorant. This truck transfer site is substantially where our current site is, but we're upgrading to concrete pads and a dual station where we can offload 2 trucks at once. We can also send LNG from these trucks directly to the vaporizers in the event we had to isolate the tank from the vaporizers for any reason, so we can continue to provide gas service through the trailers. Yeah.
Where would a railroad car park?
So the railroad car would most likely come in from this direction once we remove these tanks. Or we would come in and come into the north side in here to another offload rack. This is the second spill impoundment for the offloading facility. The rest of the equipment, our old boiler room, our old control room, meter runs, these tanks, they'll be moved, taken out. So this is the excavation of the truck unloading area. So what we're doing is removing all of the organics, the silts down to frozen gravels. You can see the ground in this area is not good for about the first 10 to 15 feet. It's full of organics, unfrozen permafrost, and it's a mess. So this has all been removed now and backfilled, and they're starting the concrete foundation work. This is what it looks like now. This first concrete pad is that spill impoundment by the trailer loading facility, and then our trucks will come in and drive in this direction, so that where you see these 2 stakes is where the truck pad will be. This is how it's starting to look. You can see all insulation under all of the concrete pads. This is the pad for the kiosk, for the truck operator kiosk, and then we'll have an area where any spills from the back of if there was a spill from the back of the trailer, it would go in and follow the pipe trench. So they're just starting to frame up the pipe trenches and the slabs related to the balance of plant. As we mentioned, there's the heat that's going underneath all of the concrete slabs so that we can keep them free of rainwater, snow, and ice. That's what you see here being placed. There is going to be a thin rat slab poured first over these concrete, over these heating tubes, and then the main concrete foundation. The reason we're doing that is in the event of a spill, we want LNG spill, we don't want these conduits to be affected by the cold. So we want to create enough of a heat transfer area that any LNG spill will not make these conduits too cold. Protect them from that. So the next steps for September, we'll be lifting the dome roof and the ceiling. They'll build the ramp for the temporary construction opening. They'll first weld in the outer tank floor and place we have 3 feet of insulating blocks on the floor before the tank floor. So there's 3 feet of insulation underneath the inner tank floor, so that the LNG, the cold, doesn't penetrate into the ground, which can also cause issues if the ground is too cold. We actually have underneath the tank and the tank foundation, we have heating loops that we may or may not have to use. We'll see how cold the LNG, the ground gets with the insulation in place, but that will create a heat break, or a thermal break, so that the cooling won't make the ground too cold if necessary.
Is there a, real-time photographic coverage of the construction? Where?
Coming up.
No, I mean, on the website.
Oh, no, it's not yes, there is. There's a couple of, each time we've had a time-lapse video redone. No, they're on the ADA website. I don't think they're on the ID website yet. No, we put them on the ADA website, so I need to get them moved to the ID website. What we've been doing is keeping, as you suggested, real-time video, and then periodically updating a time-lapse. And so what we'll do is we'll get an updated time-lapse and get it on the website. We'll continue to work on the truck unloading facility, and they'll get the multi-purpose building, the boiler building shell up in the next couple of months. And then we'll continue to work on finalizing our balance of plant orders and the final design and construction. We've ordered the vaporizers, we've ordered the boil-off gas compressors, we've ordered our boilers, the LNG pumps, the pumps that go in the tanks are ordered. So the long lead items are all ordered and expected to arrive with significant lead time in advance of the needing them. Let's see. So this is not fully up to date, but this is the time lapse from the start of construction through June 29th. I think we had some nice music to go along with it too.
Pretty good driving there.
Yeah. Pretty good.
Oh, there's your music.
But what's your workforce on that? How many men have you got on that per head?
It varies from, at certain times there was 10 to times well over 50.
Really?
Yeah.
When the pour happened, we had 50 people on the grade. We had 26 truck drivers delivering a load of concrete every 3 minutes and 22 seconds.
Gosh.
And so it, depending on what's going on.
Yep.
Yeah.
That little Denali there in the background on the right.
Yeah. Great Northwest Denali.
Great Northwest.
And that actually worked very, very well in our favor as it related to the work in the wintertime for being able to place the gravel, because they have such a large pit that we were able to break into the inner part of the pit, so we were get warm gravel, not frozen gravel. So that helped with getting the compaction necessary. All the gravels were compacted to 95% proctored. So when it's cold, it's tough sometimes to get that compaction.
Yeah.
you have to go to get all the cranes?
So the, one of them is from locally, the other was from Anchorage. The big crane that they're bringing in, the 600 ton for the lift of the roof will come from Anchorage. North Star? Alaska crane. Or Anchorage crane. Alaska or Anchorage? Alaska crane.
I think that's the same crane they're planning on using on the LRDR. Got it.
Oh, yeah, they've timed it with
Yeah.
another project to, the mob and demob of these cranes is very expensive. So. So we'll get this updated. It'll start to show some of the wire winding, other activities. But it was a late notice for today's meeting, so I didn't have time to get the request in for the updated timeline. So that's my excuse.
We called you yesterday.
Yeah, yesterday. So I apologize for not having an updated one. We will get it on the website. So that project's moving along well. We're on schedule. And so we anticipate to have it completed on schedule so that we can have it in service and so that we can apply for the storage tax credits that are still available from the state of Alaska for 50% of the construction of project up to $15 million. So that's really driving, and it has to be in service by January 1st, 2020. In addition, we're working on the North Pole storage. IGU signed a land purchase agreement and early occupancy agreement with Golden Valley, option agreement for the land. We've completed the geotechnical work and the initial or the environmental phase 1 on that property, and we are now moving to final engineering or looking for approval from the IGU board. I will be looking for approval for the engineering contract to do the necessary engineering work to complete that. The target is to complete that this summer also, so that it's in service in advance of the January 1st, 2020 date also. So the geotechnical work we did in the phase 1 environmental, we didn't find anything that the environmental engineers felt like a phase 2 was required. So we're in a position now, we've done our due diligence on the property, and we'll bring it forward to the IGU board as to whether they want to complete the purchase. The option agreement was what it was signed now, and so we will most likely be looking forward to complete the purchase of that property and begin construction in the winter 2019. And we'll be moving ultimately 2 of the tanks that are at the site that's right now out to that location. So that's what's happening in storage. We continue to look at the work on the integration of the 2 utilities. We're finalizing Pentex's audit for fiscal year 2018, and in the midst of IGU's audit for 2018, and then we'll be combining the financials for the 2 entities. What else have we got going on? We have a customer service conversion manager that's been hired and starts tomorrow. That person will be resurrecting the conversion group that was previously established. That includes community members and looks to provide guidance on maximizing conversions and programs that can do that. So we'll be resurrecting that program.
Is that the person's name available?
Yes, it is available, and it's Michelle Hollowell. She was a former manager with the Fairbanks school district in the custodial side of manage the custodial district. And we'll be introducing her to the community shortly. So we'll be hitting the ground running. What we've got is Stantec, who is providing some of the conversion consulting services has prepared a transitional document and of all the work that's completed to date and the activities necessary. There's some work going on at the borough for the air quality grants that will be making sure, or trying to make sure that those all apply to the ability to convert from to gas as well, so that those grants could be available to support the conversion program. So the borough recently reached out to me for us to participate in that, which we will do. As far as the liquefaction side, or the LNG supply side of the equation, what the storage tank does is it allows us to maximize our current LNG production capacity. By the way we operate today is we shut our LNG facility down for multiple days every week in the summertime because we have nowhere to put the LNG. With the tank, once the tank is completed, we'll run that facility all year round. During the off-peak times, any excess production we have goes into storage. So we'll fill that LNG tank, and then in the winter we can use that extra buffer, draw it down in the winter, use that to supplement basically the stored LNG, supplement our available supply, and that allows us to add about 400,000 MCF of sales in addition to our current 800,000 MCF sales. So significant addition. So it gives us a little breathing room on needing the new LNG supply source to continue that growth that everybody wants to see. The options that are being considered right now is there's been an unsolicited proposal brought forward by Siemens that is interested in constructing, owning, operating a liquefaction facility in Big Lake area, Houston area, on property owned by the Kanik tribe. And so they've presented a preliminary proposal and some draft contract language that's being considered. We have a substantial amount of work that needs to be able to be done to get to the details necessary to determine whether or not that is a valid option to be considered, but it is being considered. The other is to expand upon the existing liquefaction facility that is now owned by IGU and add another initial train, 100,000 gallon a day LNG train at that facility, and then ultimately add additional trains as necessary, as dictated by the demand.
100,000 gallons is how many MCF about?
About 12. 100,000 gallons is about 12 million cubic feet a day, about 3.5 BCF a year of capacity. The current liquefaction facility is 50,000 gallons a day. The idea, or the plan in that scenario would be to have both liquefaction facilities, the existing one plus new. There would be some new equipment that replaces some of the equipment that's at the existing, so there'd be new transport loading facilities that could take LNG from either train. There would be new pre-treatment. We have to remove CO2 and water from the gas before it's liquefied. That would be included, but it would be operated by both facilities would be operated on the same land. So we'll get to a point where we have a analysis of the options that look at the benefits, pros and cons of each, and at that point we'll be able to have the IGU board consider those and make a decision on how they want to move forward.
So Dan, kind of just to discuss the Siemens proposal a little bit more to the extent to which you can. Obviously, you're analyzing it. We appreciate that. One of the understandings I have of what they proposed is that they would take cost overrun risk, and maybe you don't know that answer yet because you haven't dug in to find out what's the words say. I guess I'm interested in discussing that a little bit, discussing the idea of the ISO units, which seems to be something that they're bringing forward, but that's always been something that we've
discussed in your proposal, you know, in your plan. So I'm just trying to get a better understanding of what they're bringing that has value. They're a credible company, they're a real deal, for sure. And so I'm just kind of interested in that. And then this connect piece, there's some arguably, I guess, better access, safety things that they might bring, but you probably don't know that yet.
Yeah.
Gotta look at it.
So I'll take the first being is they have represented that they will take the cost overrun risk related to at least what they have proposed is to install 2 LNGO systems, which is Dresser-Rand technology. Siemens now owns Dresser-Rand. Dresser-Rand's been in the compression industry, gas industry for forever. We have a Dresser-Rand compressor at our facility, a couple of them. So they've proposed installing 2 of those. Each one would have 30,000 gallons a day of liquefaction capacity. And so that's what they've proposed so far. They've indicated that they would want to install additional ones as their demand increases. But contractually, we got to get into those details of what that means, how that works. But they have represented that they would take the cost overrun risk. Ultimately, how that is captured in a detailed contract, I don't know yet. As you said, we're getting into that level of details, but at least so far they've said they would. So as you look at the utility developed approach, which would be to add a 100,000 gallon a day train, the utility would take cost overrun risk associated with that project. So in order to do a fair analysis, when we bring it forward to the board, what we'll provide is sensitivities related to cost overrun. The utility-led approach was reviewed by the name of the contractor, the consultant firm that did the review of all the previously submitted proposals when the RFP was sent out for liquefaction. They did a review of the utility-led approach also, and determined or suggested that the capital budget that has been developed and the work that's been developed so far is within a plus or minus 30% range. So what we'll do is we make sure we'll provide the IG board with sensitivities related to that. So if we have a 30% cost overrun on a utility-led capital development, what does that mean? What does that mean to rates, and make sure that we can look at the 2 in a similar light. As it relates to their location, the location is adjacent, closer to rail than the current Titan facility. The Titan facility now would be within a half mile of a rail if the Alaska Railroad was to ever build that spur that went from that was meant to go to Port Mackenzie. I don't see that as a likely scenario that they'll be building that anytime soon unless something really changes out of Port Mackenzie. So that the site that there does have a beneficial location to rail in comparison to the Titan facility. The use of ISO containers is independent. You can use ISO containers for either site. The difference between deciding to use the rail with their location would be you would liquefy straight into the ISO containers right on the rail. You would only handle it once. If we wanted to use the rail from the Titan facility, we'd have to load those ISO containers, truck them to the rail siding, load them on the rail siding, and then into Fairbanks. So we'd have an extra step, an extra piece of handling in that trucking portion, which is what we did in the pilot project as we proved out the rail concept. So that would be the difference as far as the handling. As you mentioned, the safety aspect, and I really, that one's a sensitive subject for me. Just saying that rail is safer than trucking doesn't sit as totally true to me. So each has their inherent dangers and challenges and issues. Is one more safer than the other? I don't know. Ultimately, I don't know that you can say that. When you're transporting by rail, we're transporting a lot more volume together. So if there's an incident, the impact can be larger. It's not often that you have rail incidents. Rail is a very safe way to transport goods. They transport hazmat goods on the rail every day. Propane, gasoline, oil, it's done all the time. It's not as convenient to transport on rail in that when you send your ISO containers, you don't get them back for a while, number of days. So you have to kind of batch your shipments. When you're using trucking, it's, you send the truck, you get it back in 20 hours. So each has their pros and their cons. As far as transport, ultimately transporting by rail should be less costly. So it has a cost benefit to do it that way. But you have a lot more capital that you have to invest up front, because we have right now 17 trailers in our fleet. You'll need 40 to 80 ISO containers in order to be able to get them back, to be able to be filled and ready for the next train. So that's all part of the analysis.
Okay.
And we'll move through that. What they have proposed so far, I think, is public. It was in the last IGU board meeting. And we'll be looking at a comparative using the same gas costs as what we have today. Siemens has suggested that they might have access to lower cost gas. We'll have to see. We've heard that a number of times in the past. So we'll see whether that is in fact the case or not. They've suggested that with their partnership with Connect, that they may have the ability to develop gas on their Connect's property in the form of coal bed methane. And that's got its issues. So we're going to have to see what that means, and whether it is potentially beneficial to the project or not. It's too preliminary. As I've said before, one well does not make a development for which a gas utility can rely upon. So it would require a significant development program to produce enough gas to meet the needs of our project moving forward. And unfortunately, the news from the Doyon well was not positive again. So it's still focused on proven supplies out of the inlet right now.
So just a little more granularity on the rail thing. Have you determined the extent to which they dealt with that 12-hour shift requirement of the railroad and how they stage cars? I think they assumed that they dealt with it. Have you independently looked at that at all?
No, we have not yet. We just received the updated Siemens proposal on Friday. Okay. Or a week ago Friday now, sorry. The Friday before the last IU board meeting. And so we haven't got into confirming their assumptions related to the number of ISO containers that they would need. Those were kind of discussed at a high level in their proposal. So we have to get into those details to confirm. What they have suggested is that they would be responsible for the shipping, although the contract with the rail would be with IGU. I think there's some flexibility there. That's not set in stone, but that's how they've proposed it in their initial proposal.
Thank you. Thanks for responding.
So with that proposal, there was a public part of it and a confidential part of it, business confidential. Did you get the business confidential piece?
I did.
Okay.
Patrice?
Dan, we're in transition right now. Could you talk to us a little bit about security of supply for this winter?
Sure. So the security of supply for this winter is we're relying on the existing Titan facility and their storage that's in place. We maintain a minimum of 5 days storage. We also have interruptible customers, so in the event we have any problems going on at the liquefaction facility, we can interrupt our larger customers, the hospital, the university, to the extent they're using school, a number of large customers. So we would use that to minimize the demand at the time of challenge in supply. Unfortunately, the ConocoPhillips LNG plant that we had a backup agreement with previously is now warm. There's no LNG in those tanks, so we can't rely on that backup. So it was great when it was in place, and we're hopeful that they build that again now that it's owned by Endeavor. I'd love to see that facility become an asset that's useful to the state again. So Other than that, if we have a challenge with our liquefaction, at Point McKenzie, we'll have to look to get some LNG supplies out of Canada or other regions. And it's a challenge, it's difficult. But what we do to minimize that is the liquefaction facility can operate in a number of different scenarios. If we lose a single compressor, we still produce partial volumes. If we maintain in our inventory in stock complete compressors and engine or motors for our refrigeration compressors. So we have the way it's designed is we have the propane compressors. We have 2 of those operating in service, and we have a third in our warehouse. In the event one of those fails, we can have that changed out in 2 days. Our engines, we maintain a complete rebuild of our engines in inventory between ourselves and our service company, so that if we have a failure on an engine, we can have that engine rebuilt within 3 days. And I'm talking an in-frame engine overhaul, pistons, everything. We stock all of that. So we do everything we can to make sure we can respond to any supply issues. So it's a combination of ability to produce in various different levels at the plant, making sure that we have spare parts for issues that could arise. The storage facilities, we have 2 storage and vaporization facilities, so if one's disrupted, the other can produce in Fairbanks. Our LNG transport fleet, we have 17 trailers in our fleet now. On any given day, we'll usually be moving 6. So we have a substantial amount of excess in our fleet. We also keep those full in the winter, so in advance of their need, we'll use those as what I'll call additional storage. So we'll fill a bunch of those trailers in there, so that's pre-made LNG before it's needed. So we maximize the amount of stored LNG we have, and then go from there.
Can you explain the process of liquefying natural gas?
Sure. So essentially what we're doing is just cooling it. And you can do that many different ways. We can take a coil of natural gas and run it through a tub of liquid nitrogen. And out the other end, depending on the flow rate, will come a frozen methane, and it'll plug up, or if you have the right flow rate, it will just be liquid. So because nitrogen's minus 320 degrees, LNG, natural gas, liquefies at minus 260 degrees. So we're cooling it. And you can cool it in all sorts of different ways. One is through the way I just said, I could make LNG right in this room if I had nitrogen, liquid nitrogen. But the way we do it at the plant is we cool it with refrigeration, similar to air conditioning. But the refrigerants we use is propane and then ethane and ethylene. So that refrigerant, we take it through an exchanger where we cross-exchange the methane with the ethane and ethylene. It takes us down to about minus 100 degrees. We then take it through heat exchangers in what we call a cold box that takes any flash gas from the methane that's in the trailers and uses that cooling, cools it further. And then the final step that we use is expansion. So we take from 1100 psi or 1000 psi down to 150 to 180 psi, and that expansion creates energy, and we remove that energy, which creates the cooling. And that's what creates the final cooling step in our process. Where we're looking for, and then the Dresser-Rand process is similar to that. They use ammonia for their cooling, but they use a combination of cooling and expansion. The approach to a Titan expansion would most likely use a nitrogen cycle, and what it uses is a nitrogen system to create the cooling of the LNG. So there's also, and there's mixed refrigerant systems. There's many different types of refrigerant approaches you can take, but essentially you're cooling the gas to minus 260 degrees.
Not under pressure.
It is under pressure, so you can do it under pressure, or you can take it down to, and your final cooling, depending how cold you take it, you could subcool it down to where it's essentially 0 psi LNG. Right now, our process, we make our LNG at about 30 psi. Depending where it is in the process, it comes in from the pipeline at high pressure, anywhere from 700 to 1100 psi, and then in the final step, we drop that pressure down, flash it to LNG.
I have a question on the safety. I understand the comparative safety between trucking and rail. I understand it's not apples to apples comparison, but it seems to me that you should be able to quantify the comparative risk, or somebody should. For example, if I went out to buy an insurance policy, and I go to my insurance and they say I've got a trucking operation or I've got a rail operation, I want the same amount of coverage, I want the same premium, the same deductible. I'm gonna have two different premiums because an actuary determined that one's riskier than the other. So, I mean, if you could speak to that.
Yeah, I've never done that level of analysis between the two. I guess there'll be a lot that goes into it, right? So how many rail cars are you transporting at a time? When you batch the ISO containers, right now the rail permit, I think, only allows them to transport every 4 days and only a maximum quantity. So there is some permit issues that we have to deal with as well on the rail for long term, but it'll depend, you have one rail car, one LNG car on the rail, or do you have 100? And so we'll be batching the rail car, so we'll have multiple numbers. So whether or not we actually do that final level of evaluation between the two, and that'll be up to the IG board. I'm sure somebody could try and quantify what those risks and look at the total incidents per movement in the rail versus total incidents per movement in the trucking industry. Quantify that. We've been transporting LNG in Alaska via truck since 1998. We right now do about 1,000 loads per year, and we have done so without any damage, third-party damage from spill of LNG. So we have had a few truck incidents in our time, none of which have resulted in any environmental damage or any fire or explosion. So it's been done safely. But
when this is being transported either by rail or by truck, is it all before the odor is added, or is there any difference in the different proposals in terms of that?
No difference there. That's really just LNG is minus 260 degrees. Any odor in that LNG would freeze out in a block. Mm-hmm. So LNG, when it's transported, is unodorized gas. Mm-hmm. So any spills or leaks need to be detected by leak detection at that point. So, and there's no difference between the Siemens approach or our approach. Yeah, that's the reality of LNG.
Yeah, isn't some of the transportation concern down in the Matsu localized when you're moving the trucks to the Parks Highway through those secondary roads?
That's been some of the concerns that have been vocalized by Connect. Those concerns we've not had conversations with Matsu officials with regards to concerns. Those have been concerns that have been vocalized by the Siemens and Connect proposers.
Other questions?
I guess just one. Dan, when do you expect gas to be available in the North Pole area? Air quality is an issue on out there. When do you expect to be able to start marketing and supplying?
So provided we are successful with completing the storage facility in North Pole in our desired schedule, it would be the beginning of 2020. So we would have that North Pole storage facility operational by January 1st of 2020. So we'd be looking to provide gas service into the currently installed distribution system.
Can you assess that demand at all? Is there any commitment or expression of interest? Is there any way to know how many people will say, okay?
There's been a lot of work done on demand studies. The IGU did surveys that were completed in North Pole, and depending on the price of oil versus the price of gas at the time dictates the level of interest. There's a substantial amount of interest, I think, that was brought forward. That those surveys have not been renewed since they were initially completed. So, we've got on the FNG side, we continue to get inquiries. We are adding service right now for interruptible customers, primarily commercial, or only commercial for interruptible customers, but there's a high level of interest still from that. So, the demand's going to be an issue, and it's a community issue that we need to work together on. It's not just an IGU issue now. It's everybody. It's the whole community. This is the community's gas company.
But there's not like a waiting list where people who want to be there.
Not a definitive waiting list yet. I mean, we took a while to get to where we are today. We've come a long way from where it started, and but we're there. We're building storage at both locations. We've got a consolidated single utility in our community now. We've got liquefaction capacity that we have. We've got options for adding LNG production. So we're just moving through the details of what's best. And we need to work together on moving through those details now. And we need to be pulling in the same direction. We've kind of had, a little bit of challenges and opinions and things of how different things should have gone as it relates to purchases and sales of Pentex or not. Those are done. They're completed. And we have a single utility in our community that we want successful. And it's going to take everybody's commitment, and that's going to be to conversions also. It's an individual person's choice on how they want to contribute to the quality of life in their community, and air quality is one of those issues. So hopefully people will recognize the benefits of gas. I think they will. Once you've used gas, you will never go back. It is the best energy choice as it relates to home heating, cooking, dryers, everything, all those options. It's so convenient once you have it. You just wonder why you had to deal with oil for that long. So we look forward to that.
Once you have the storage ready to take gas, even if you don't do any expansion on the current Titan plant, how many months or years would it take with off-time operation of that plant to fill those storage tanks?
Take a year to fill the storage tanks. Yeah. Takes about a year.
And how many more customers would you be able to add? So without any gas production expansion, just by having those storage tanks full?
The number of customers depended on the profile of the customer.
But residential, say.
So about 2,600 residential customers.
You could add.
Yeah.
Do you need a certain number of customers in a neighborhood before you can turn on the supply?
No, the gas in the FNG system, in the Fairbanks system right now, all of the pipes that were pre-installed, I'll say, in advance of additional supplies, those have gas in them. They're part of our total system. We just don't have the capacity to add customers. But tomorrow I can put a service line in any one of those communities and turn the gas on in the summertime because we have the supply. It's just in the winter we would be we would be pushing our peak demand versus our storage beyond. We would be out of sync with that 5-day requirement.
Are there 2,600 customers along the existing infrastructure?
More than that, yeah.
I have a question about conversion capability. If I leave this meeting and I go call my pal out there on North Pole, and I say, you could hook up tomorrow, because last conversation we had about it, she said, that's the last thing we'll do. They built their house when they had money. They don't have money now. They're barely hanging on to their house. And they can't afford to convert. What can I tell her?
You can tell her that we're working on programs that will provide conversion assistance. So what I just mentioned, the air quality grants, I think they're called. The borough's working on making sure that those can be used for converting to natural gas. We've been working with the delegations in DC and trying to find whether there's any other programs that can be brought forward to help people with conversions. We don't have a silver bullet yet, but everybody's working on finding those solutions. And that's, getting the conversion program committee back up and running. That's a community-wide issue that we'll all have to work towards, finding ways to provide additional incentives for people for their conversion to help them.
Will IGU have on-bill financing?
We will will have the capability to do on-bill financing that takes some more analysis to determine who's gonna be liable for those debts and how that's all gonna shake out. But that'll be one of the considerations for making it easier for people to convert.
Patrice?
On the targeted airshed grant, I just wanted to mention that, the EPA has just rules about how that can be used, and they are working to see if it can be used. If the requirement is that it reduce PM 2.5. And so if your program does that, then you can be, but it's only $4 million basically at a time so far. So it's not enough money to, I hear it being talked about a lot, and it's really a very small pot of money. And there are other competitions for it within the borough by existing programs and whatnot. So there has to be a lot of massage about what will stay, what will go, and prioritization. So that's an issue. We need funding sources to help with conversion. There is no doubt about that. So if anybody's got their connections, because people aren't, if you put on bill financing and you calculate that into the amount you're paying for your gas, that can add anywhere from $3 to $7 per MCF of gas. And you can't just say that it's not an additional cost to the customer in terms of gas. So.
Okay. John?
I just want to say, so I worked a little bit on the early version of the conversion committee, and there's quite a range of people's capacity to deal with the conversion issue. There certainly are some people that are at the low end of the financial spectrum where hooking up is a big challenge. But on the other hand, there are people at the other end who told us in the surveys they'd hook up tomorrow and it didn't matter what the cost was. They'd pay for it. So there's this whole range of people that are out there that are that we need to get hooked up. And there's a range of there's some people already have oil boilers that for a fairly small amount of money can be converted. There's others that are where their boilers at the end of their financial life and they should be replaced anyway, and they're just going to have to do that. And probably some of those will pay for it, and some of them need some assistance. So there's a whole, it isn't that every single person that hooks up needs to have a $10,000 conversion assistance package. It's a range of issues.
Yeah, but something that hasn't been talked about here, which may or may not be significant, sounds significant to me, and that is that I listened to the proposal from Siemens, and they talk about getting their own bonding, getting their own financing. And it seems to me that would free up bonding money. I don't know if you're in a position yet to say what that could mean, but it seems to me like that frees up an enormous amount of money, an enormous amount of options for all kinds of possibilities. Can you respond to that?
Yeah, so Siemens will finance their projects that they're developing on their own. So IG won't have any responsibilities related to financing. But what they have suggested in their proposal is there'll be a fixed monthly fee, a demand fee that will cover their financing costs, their fixed costs associated with providing the service. So we are trading debt that we hold to bond for liquefaction capacity with an obligation to pay that fixed fee. So whether or not that has any benefits financially to the entity depends on what that obligation looks like. Is it an obligation that requires backing by other lines of credit, by your financiers? I don't know yet. So, but if you're obligated to make a payment, that goes in your financial statements, and that will offset any ability to go get that additional debt because you've got this other obligation. Your capacity to obligation, whether it's an obligation to pay a fee or an obligation to pay a debt, is total. You have to look at your total capacity for those things, those two things. And ultimately, it's the same usually, depending on how that obligation looks. Now, I don't know what that obligation looks like yet because we haven't seen those details, so I can't say for sure. But what they suggested is that IGU must be creditworthy. In their proposal to the board, they suggested that they think that may require some backing from somebody, but again, we don't know yet.
How bondable is IGU currently?
We're working on that. So we've got some financial advisors that are just starting to take a look at the IGU finances. We'll be starting to have discussions with bond counsel on what a bond package might look like. Ultimately, the bondability of IGU will be dictated by our success in conversions. The program that was set up with ADA with the deferral of the SETS loan for 15 years, and the fact that the SETS loan takes a backseat to any bonds, substantially helps IGU's bondability, makes it a lot more attractive than it would have otherwise been. So the SETS loans with ADA, not only do they have the 15-year deferral, plus additional potential deferrals if demands aren't what are expected, they also have agreed to take second step to bonds, so, which is a big deal. That's a huge deal as we go out into the bond market, because if our first lender would have needed to be in first lien position, that would have put bond holders in a much more challenging position. But given that the SETS loans will take the second position, bond holders will have first position on all of our assets.
Okay. Trace.
Dan, I've got a quick question.
Amount of.
Hang on a minute.
Oh, sorry, if somebody else wants to let them go.
Okay, Patrice has sold the floor to who is ever on the phone.
Hello, this is Richard Green. Good morning, Dan. I showed up a little bit late here, so if the question I have has been answered, you can just forego it. But my question is there any looming in the future, any political footballs we have to be worried about, or has our process and the gas gates been open enough that we are away from the political process?
Well, I think, as you probably have seen in the community and in the news media, no, we're not out of the political process yet. Unfortunately, we're still looking backwards. It's time to look forwards on the project, and I think that, you know, we're in a good position to be able to deal with any political issues in the future. What we have is a community-owned gas utility, community-driven project to bring additional natural gas supplies to more people with the goal of improving economics and improving our air quality. It doesn't get much better than that at the end of the day. We have challenges, yes. The conversion is an issue.
Okay, thank you.
wait for the sunshine to come up.